Hello everyone. So welcome to week 6 practice problem number 3, voter registration. During voter registration, the Commission on Elections help register a voter waiting in the queue one by one. We assume that registration times for different voters are independent and identically distributed. Suppose that the service time x sub I for voter I has a mean, 5 minutes with a standard deviation 3 minutes. Okay, so this is a central limit theorem problem because we have here sum of independent and identically distributed random variables, capital Xi. And we have here sum of 100 or a lot of random variables, okay? So we can solve this by, so for the first problem, we want to get an approximation to the probability that the total amount of time, let's denote that as S sub n, which is x sub 1 plus x sub 2 plus x sub n, the probability that the total amount of time, probability Sn, is less than 440 minutes. So that is what we want to obtain for the first problem. So first, we have here, mu of a single random variable. This is equal to 5. And we have here the standard deviation of a single random variable, sigma x is equal to 3. And by central limit theorem, we know that the mean of the sum is equal to n times mu. Okay, so this is equal to 5n depending on the number of random variables or number of participants or voters. This is mu sub Sn, and sigma Sn is equal to 3 square root of n, right? Or sigma square root of n. We now have this S sub n, to be a Gaussian random variable by central limit theorem. We want to obtain, once again, if we have here n is equal to 100 voters. This is stated in the problem, right? 100 voters. So if we have 100 voters and the mean of a single voter is 5, therefore the mu Sn is equal to 5 times 100, 500. And the sigma Sn is equal to 3 times 10, 30 minutes. So this is at 500, centered at 500 with standard deviation equal to 30. So this is the critical point here, 440. We want to obtain the probability that the total amount of time to register those number of voters is less than 440. So we want to get this probability. So to do that, we can standardize this Gaussian distribution, by subtracting minus 500 over 30. And to get this critical point, in the standard normal distribution, z is equal to 440 minus 500 over 30. That is equal to, z is equal to negative 2. And to get the probability that Sn less than 440, we have to get phi z is equal to negative 2. So let's console the table. We would obtain 0.02275. So that is the probability that the total amount of time to register 100 voters is less than 440 minutes. So the next problem is find the probability that registering 10 voters will take exactly 60 minutes. Use CLT with appropriate correction. So how do we do this? We have here mu Sn is equal to 5 times the number of voters in that problem, 5 times 10. And we have here sigma Sn is equal to 3 square root of 10, right? So if we want to get approximate probability that it will take exactly 60 minutes, we obtain, okay, 60.5 minus 5 times 10 over 3 square root of 10. Get the probability of this, okay, and also the probability of 59.5 minus 5 times 10 over 3 square root of 10. Because when you plot it, okay, so for example, okay, this is the Gaussian distribution. And for example, we are centered at 50, okay, and we are trying to get the probability, the exact probability that it is exactly at 60 minutes. Then we can just, okay, get 60.5 here and 59.5 here and just get the area between these two. So this is what we are obtaining. This is, once again, this is just an approximation. So if you want to do that, just consult the table. Okay, we will now get, okay, this is the probability of S sub 10 equal to 60 is approximately equal to 0.02413. Okay, so that's how you solve this problem. See you on the next problem.